We are looking at figure 21.1 on page 445 of your textbook. So let's assume there are two countries, Angola and Zambia. The textbook talks about country A and country B. That's fine, you can call it whatever. So let's assume both of these countries have factories and are emitting some kind of pollutant like sulfur dioxide. They both have the same amount of factories and they both emit the same amount of sulfur dioxide. But the difference is the wind in this case is blowing really strongly from west to east. So we have a very strong wind going eastwards, meaning it carries some of that pollution to the next country. So Angola loses some of its pollution in the wind and it carries it over to Zambia, while Zambia loses some of it altogether. Maybe it goes to the sea or to the next country or whatever. So now we have a situation where, although they emit the same amount, Angola only have a certain amount of emissions in the country, and Zambia is exposed to twice that amount, where one of those emissions came from country A and the other was of their own wrongdoing, while Angola only has some of their own emissions. Now, how would this look on a graph? Let's draw the label the axes first. The marginal abatement cost curve is just a normal one. But then we have the marginal damage curves, and I want to focus now on the country Zambia. So let's say the marginal damage curve of Zambia is over here. So this is only the pollution that's actually caused by Zambia. So it's only the B or Zambian pollution, right? But now we also want to take into account the pollution that came over from Angola. So we have another much higher marginal damage curve, which I'm going to call total, the total marginal damages. So Zambia might think they are over here because if they look at their own emissions, they say we have to emit E1 and it will cost us this marginal damages of this amount, right? Now the amount they will pay for total damages in this case is this area under the marginal damage curve. Remember, the total is equal to the area under the marginal damage curve up to the point where they emit. But this isn't really true, is it? Because actually they should be over here, because this is the true amount of emissions in the country, the much higher marginal damage curve. So they should actually be lowering the emissions quite a bit, because they didn't take into considerations the pollution that came over from Angola. Can you see the damages is actually quite high? It's this area over here. Because we have to actually look under the total marginal damage curve to find the total damages. Okay, so that's the actual total damages, right? So they have to reduce it somewhat. And they have to reduce it to E2 in order to only get this amount of total damages. Okay, so this area over here, which was previously green, it's not anymore, it's actually the responsibility of Angola, the other country, to reduce the emissions. And this one over here is the responsibility of Zambia. So can you see why it's important to be able to have bilateral agreements? Because I can't sue someone in the other country, take them to court, because their law does not apply to me and my law does not apply to them. So we should have politicians that negotiate on these type of agreements in order to get to a sustainable and an efficient level and a good agreement. Because currently the country that's against the wind is receiving a lot more damages than the country that's actually emitting it. So very important. You should be able to draw it. You should be able to explain it, especially in terms of bilateral agreements.